The problem is to find the limit of the infinite power tower of e as x approaches infinity. Titration is defined as iterated exponentiation, where e is raised to the power of e repeatedly x times. The limit y equals the infinite power tower of e, which is e raised to the power of e raised to the power of e, and so on infinitely. By the definition of the infinite power tower, y equals e raised to the power y itself. Taking the natural logarithm of both sides gives ln y equals ln of e to the power y, which simplifies to ln y equals y. From ln y equals y, we rewrite it as y equals e to the power y, then multiply both sides by e to the power negative y to get y times e to the power negative y equals 1. Multiplying both sides by -1 gives negative y times e to the power negative y equals -1. Applying the Lambert W function to both sides uses the property that w of negative y times e to the power negative y equals w of -1. Since w of negative y times e to the power negative y equals w of -1, it follows that negative y equals w of -1. Solving for y gives y equals w of -1. Therefore, the limit y of the infinite power tower of e equals w of -1. Because w of -1 is a complex number, y must also be a complex number. Since y equals infinity and y is complex, it implies that infinity is an element of the complex numbers. We define y as complex infinity, denoted by a special symbol to represent this concept. Hence, the limit of the infinite power tower of e as x approaches infinity equals complex infinity in the complex number system.